Hello, am I audible?
Yes.
Yeah, so shall I start? It's been 10 minutes.
Yeah, I think you can start.
Okay, so the agenda of today's session is to learn some coding principles. So the first question is why do we need to learn them? So uh, just a minute. Yeah. So the first question is why do we need to learn them? So the first the first thing that I wanted to tell you is like almost all the developers, almost all the developers in our company as well, is spending 80% of the time on fixing bugs and improving the existing code, right? Uh, so we spend most of the time in cleaning our code or somebody else's code. So how to make that life less miserable? Because obviously understanding some another developer's code is a bit tough if it is not written properly. And given even if you like code in latest Android version, latest Android SDK, latest Android components, it cannot improve the code automatically. It is not gonna fix it automatically. The bugs will not be being removed if you like just ports from Android Q to Android R to Android R2, the new OS, and so on. So there are some basic coding principles that every developer need to have in mind while coding. These are not oops concepts that we studied in our college times. These are, like, you can say, guiding principles. So for example, as you can see in the slide as well, when the developer builds a software following a bad design, the code can become inflexible and more brittle. Now, what is this inflexible means? Inflexible means, you can say, some small change in software can result in bug, and moreover, you cannot reuse the code again and again, uh, given if you have a new functionality to implement. So talking about these solid principles, Robert Martin, a great software engineer, he wrote a white paper in 2000 which refers to these principles. So this was like a major revolution in the field of software development. Even the architectures that you see these days, like clean architecture, MVVM, MVC, every architecture is one way or the other depends on these principles. So these are the building blocks. Let's suppose if you are learning MVC or clean architecture, you need to have these five principles in mind every time. So uh, let's say your product team, our product team, can give us the new implementation anytime. So what if it breaks our existing code? Because we are assuming that, let's suppose, if our code is tightly coupled, then the reusability and working with the code becomes difficult. So let me tell you what is tightly coupled means first. So like, it is nothing but changing functionality in one file should not affect the functionality in another file. If that is the case, then you can say your code is not coupled. But if it is affecting the functionality of one file to the another file, when you change the another file, then it is tightly coupled. So if you follow solid principles, these type of problems can be solved. So yeah. So now let's go to the first principle. So the first principle, solid is basically an acronym. So the first S is so the first letter of solid is S, which is S stands for single responsibility principle. Now what it says is that a class should have one and only one reason to change, meaning a class should have only one job. In real day example, for software development, we have multiple people doing their jobs. Like, designer is doing designing, tester is doing testing, developer is doing development, PM is managing the releases and all. So every one person will have one responsibility. So that is how the whole company works smoothly. So a class should have one and only one reason to change. That is, a class should have only one job. So let's go to some example. There is a class employee. There are two functions. First function is calculate pay, and the second function is save. So what calculate pay does is it calculates the pay of the employee for the employee, and it saves the employee object into the DB. So by glancing on it, everything seems fine. But if we see closely, it is coupled, and we can't reuse the code. For example, if we want to, because we are doing like business logic also in this function, calculating the pay, and we are doing the persistent logic, that is the database operations also in this class. So we cannot like reuse the database operations, database class, database function anywhere else if we change the employee class. So mm, why, just a minute. Yeah. So that was the problem. So now what can be the solution to it? If we make like two different class, one for business logic related, uh, one for business logic related, and one for the repository operations, then it will be loosely coupled as well as it will be reusable. Like see, we have made one class, employee class, which is calculating the pay and have all the business logic related to the employees own things like pay or any other type of things. And we made one employee repository class where we are storing the employees database, and we can have another CRUD operations as well, any type of database operation in here. So that's how we can like ensure that single responsibility principle is being followed. So now let's go to another slide. Yeah. So it is similar to the previous example, but see, here this handler class is basically handling everything. It is sending API requests, it is parsing the data received from the APIs, it is saving all the data to DB. So maybe I'll give you 1 minute to think. You can think of your solution in your mind. You don't need to tell the solution to me. After 1 minute, I'll discuss the solution. How can we enforce the single responsibility principle in this case, given this code? So yeah. Uh, yeah, and one more thing, you can see this code is also working fine. This is not a bad code, but is it loosely coupled? Is it are the all the APIs reusable, given we change the handler, we change the functionality of handler? So yeah, you can think. I'll wait for another 30 seconds. Yeah. So let's see if you thought is correct or not. So let's suppose, uh, uh, yeah, yeah. So this is the solution. What we did is we made three different handlers, and in the main handler, we will reuse these handlers that we have made. For example, API handler is only doing the API requests and the response part. Parse handler is only doing the parsing of data, and let's suppose creating the array or like sending the output. And DB handler is only handling the database operations, that is saving to DB. So now API handler will request the data to API. After that, that data will be sent to the parse handler, and then parse handler, and then from the DB handler, the data from the parse handler, we will save the data to DB. So what it achieves, first of all, it achieves single responsibility. The second thing it achieved is reusability. Now given, let's suppose you had a new module, afterwards. So you can directly reuse the parse handler or maybe DB handler or API handler automatically into your new code. So there is no dependency, there is no coupling. So yeah, so basically that was this single responsibility. So let's go to the another principle, that is O. So O stands for open and closed principle. So now what it states is that software entities should be open for extension but closed for modification. Software entity means everything that we define in our software, in our code. Let's suppose it is a class, it is an object, anything which we define should be open for extension but should be closed for modification. So let's take a real day example. After making a house for 2 levels, let's suppose it is a first level and it is a second level. So you cannot modify the house at the base level. uh, what I'm trying to say is, if you need to have a basement now, you didn't made the basement and you made the first and second level, now you need to build the basement now. It is near to impossible to make a basement out of it. So your house must be closed for modification, but yeah, it is open for extension, because you can make the third level in your house if you need. But if you like try to make the basement, uh, you are disturbing the foundation of your you are disturbing the foundation of your house. So thinking it thinking the same concept in the software designs, software pattern, software development also, you can say that if you change the existing code, if you change the existing functionality, it may break the it may affect the existing functionality, as well as it will not the new functionality will not also be robust, you can say. So every time you should extend the class, you should not modify the same class that was already written. You should extend the class and then do whatever you want. Yeah. So even in Android SDK also, all the classes are closed for modification. Every class is closed for modification. That's where OEM like OnePlus does their work. For example, there is a class called OP Toast in our code. I think everyone must have seen this OP Toast. So it is nothing but OnePlus Toast extending the Android's Toast. So OP Toast extends Toast. So here you can see we have modified make text. We have modified the make text according to like OnePlus needs, and yeah, and also we can modify any API that we want, like make text or like show or any other API that this OP Toast, this Toast has. Or maybe we can introduce new APIs as well if we want. If we want to have some new APIs, then also we can define it. So there are many more classes like OP Toast, OP Alert Dialog, and many more, etc. So all the Android SDK files are also following this open and close principle. So let's take the example. Uh, so here is a payment manager. Here is a class payment manager, which is used to pay with some payment type. So for example, let's say if the payment type is cash, then do something. If payment type is credit card, then accept payment and do something. So now, what if I need to add a new payment type? Let's suppose I need to add a payment type UPI. So I need to modify this class. I need to modify the existing class. I need to have one more else condition. Sorry, one more if condition. If payment type is equals to payment type dot UPI. So that's not we want, right? Because obviously we don't want to change this code. So what we can do? So the first solution that will come to our mind will be this. We will say, okay, uh, uh, let's make a payment class where we will have a function pay. Then let's make a cash payment class. Then we will override this function. let's make a credit card payment. Let's make credit card payment class, and let's override this. So now, uh, just a minute. Why this cursor is not working? Yeah. So yeah. So this solution we will do, and it is not breaking any functionality, as well as our the original base payment class is open for extension, but it is closed for modification. So every time we need to have, like, for example, UPI payment class. So we will just make a UPI payment class which extends payment and define the pay function as per our need. Yeah. So let's take one more example. There is a class rectangle having its properties. There is a class called area calculator to calculate the area of the shape. Now, if you see, it is following single responsibility principle. It is not you cannot say that it is not following single responsibility principle. So this is exactly what we want as per the single responsibility principle, because only one class is having only one purpose. Rectangle is having only the purpose related to rectangle. Area calculator is having its own purpose, that is return the area after calculating. So so uh, let's suppose there is a new requirement that is given by our product manager, that he wants to now calculate the area of circle 2. Now what you will you now what you will think, you will think that, okay, yeah, it is very easy problem. We will just make a class, we will just make a circle class, and try to, like and try to do this. But okay, so let's give you one more minute. Think of the problem, what the problem it has, because it is correctly following the single responsibility principle. So what thing it is breaking, from which we can say that it is breaking the open close principle. So yeah, you can think. You can see, we have made the if conditions, like if shape is rectangle, if shape is circle. Let's suppose there is one more shape, then we will just add one more else. That else, if shape is that xyz, then we will calculate its area. Yeah. So I'll tell you the correct solution. Obviously it is wrong. Why it is wrong? Because you see, you are like just increasing the if conditions again and again, right? So automatically, you can say that every time a new requirement comes, you are modifying the area calculator. So that's not what open close principle tells us. Open close principle says that every class should be open, close for modification, but open for extension, right? So obviously, putting the else conditions every time is not a good solution. So now, what is the correct solution? So the correct and most robust solution will be to make an interface shape and one function area in it. Let's suppose it will return double. So we made this interface shape. Now every new shape as requirement comes, we will just implement this shape, and accordingly we will define our own area function into it. For example, rectangle will have width into height, circle will have r square, or like that. So let's suppose, okay, and yeah, and also area calculator is also, you can say, uh, i- is also having the single responsibility, following the single responsibility also. And it is not, we area calculator is not uh, changing as we are adding more shapes, because what we are doing is we are just sending the shape into it, and we are just calling returning shape dot area. So every class is following this open and close principle, and yeah, you can see everything is so robust. You can add any much shapes any you want, so nothing would break. And yeah, one more thing. Let's suppose you are writing test cases, you are writing unit tests. So already you have wrote the unit test for area calculator class because it was already there in the previous code. You have already wrote the rectangle unit test also. So if you like add else conditions again and again, then you need to write the test cases also again and again, so it will like increase the work to a very greater extent. So if you do this type of thing, then already you have written the area calculator test case, already you have written the rectangle test case. So now just you have to write the circle unit test and you are good to go. So now let's go to the third principle. It is SOL. So it is Liskov's substitution principle. So what it says is, first of all, there is a like very fundamental term in our software, in our computer science, which is called correctness. Uh, I'll tell you what correctness is. Correctness is basically uh, in a computer program, in a computer software, in an application, if S is a subtype of T, then objects of type T may be replaced with object of type S without altering any of the desirable properties of the program. So like in simpler words, if you see, it is nothing but a subclass should behave in such a way that it will not cause problems when used instead of the superclass. So everything that you are like doing in the super class should have the same functionality in your subclass. You cannot like replace the functionality of your subclass. So matlab, it is a bit complex principle. And yeah, one more thing I'll tell you afterwards in coming slides, that it is not true every time, because obviously you may need to have a different behavior in your subclass. That's why you have created a subclass from its superclass, because you want to follow this open and close principle. So you said that, okay, I want to follow this open and close principle, so I will just create a new subclass from my parent, from the superclass, and I will implement my own things, own things basically. So yeah, so let me give you some example to make it more understandable. So I took this example from like from clock module. So like there is a fragment, there is a fragment called alarm clock fragment.java. So in that there is a onFlate function, right? So alarm clock fragment is extending the fragment. Alarm clock fragment is our own fragment, and fragment.java is Android's SDK base class. So there is a function called onInflate. Now let's suppose we created this function. We overrided this function onInflate, but we didn't call the super.onInflate here. If we didn't call super.onInflate, what it will do is it will not call this code. It will not like, for example, m called is equals to true, and if host activity not equals to null, m called is equals to false, and onInflate. So this code will not be called, right? So now what we did wrong is, if we didn't call super.onInflate in our like child class, what will happen? We broke the basic fragments functionality. Now what Liskov substitution says, if we replace our alarm clock fragment.java to fragment.java, then it should work. So if we have broken this functionality, now it will not work. Like for example, whenever you code, matlab, you can say that it is you can keep this thing that I'm telling uh, every time in your mind when you're coding. Whenever you code, think before extending a class. Will you be able to replace it with the parent or not? If you like if you cannot replace it with the parent at any time, which means you are not doing correctly, this part correctly, you will not be able to follow Liskov substitution. Now you will say that if that is the case, we will not be able to extend our extend the functionality of anything. Like for example, in open and close principle, there was a circle class and there was a rectangle class. So if we are not if we are if we cannot define the area function as per the child, as per the child class, for example, area of rectangle is different, area of circle is different, then there is no way to follow this Liskov substitution principle. So yeah, you are correct. Liskov substitution principle does not work, and it is not like mandatory, 100% mandatory that you need to follow it. But yeah, for Android developers, you can say that it is like following, because for every parent class you need to call the functions like super dot on inflate, super dot on create, etc, etc. So now let's go into the quick example. There is a base class employee, and now we have two types of employees. Let's suppose we have two types of employees. In our company also we have two types of employees. There is a casual employee and one is contract based employee. So like if we override this function, let's suppose uh, get project details from the employee class, from the parent class, it should have the parents functionality as well. Because let's suppose we are doing some base 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 things which needs to be there for contract also and casual also. So like just you need to call base dot get project details every time. So if you are like not calling this thing for contractual employee dot java, so it will not work. So yeah, and also I have already told you earlier also that it is not mandatory to follow. For example, I just told you the example of circle and rectangle. Let's take one more example of square and rectangle. By open and close principle, we will extend rectangle to create a square, right? But it will break Liskov's principle because we will not be able to change the height, because height and weight of square are same. So if we substitute the square class from rectangle class, then the functionality of square will break. So yeah, so it is not mandatory. So now this was a solution for it basically. Uh, yeah. So now this example will make you understand this principle in a better way, because I think this Liskov substitution principle is a bit tricky. So please focus on it. So see, there is a you made one class, bird class, where there was a functionality fly. Now you wanted to make a duck class which is extending the functionality of bird. So you just did public class duck extends bird. Now there was some requirement or anything, and you had to make a ostrich class. Now you know that ostrich is also a bird. So what you did is public class ostrich extends bird. Now ostrich is a bird, you are right, but it can't fly. So matlab, if you think closely, ostrich cannot extend the bird. Ostrich cannot extend the bird because ostrich can't fly. So ostrich class shouldn't be able to use the fly method, because we are this means we are breaking the LSP principle, Liskov substitution principle. So this is the solution to it. If we make a class bird, then if we make a one more class called flying birds extend bird and make the fly functionality into that, then what we can do is we can do something like that: public class duck extends flying birds, and duck is having the fly functionality. Now ostrich cannot fly, so we did like this: public class ostrich extends bird. So it will not break Liskov substitution also. And like if you see closely, it is following the open and close also and single responsibility also, because every class is having only one responsibility. So that's why this flying birds class came into a play. Like flying birds is having the functionality of flying the bird, of the method fly. So it is following the single responsibility as well. So I think like it will be more understandable now, I think. Yeah. So let's go to the another principle. So from I stands for interface segregation principle. It is very easy. So what it says is clients should not be forced to depend upon interfaces that they don't use. So basically, like, don't force clients to implement interface which is irrelevant to them. So like the real day example, if you want, uh, you can think of a restaurant. There is a food menu. Generally, if you see, if you like think, in the restaurant, there will be three menus. First menu will be vegetarian, the second menu will be non-vegetarian, and maybe the third menu will be for drinks, because vegetarian person will not be needing non-veg menu, and a non-drinker will not be needing drinks menu. So we need to like have three or more menus, so that uh, we are not forcing the customers to look into that menu which is not irrelevant to them. So let's check this example. We are defining an interface I employee, where we are like having the two details. It is the same example as we checked in the list scope substitution. There is a interface called I employee, and there are two functionalities in it. We can have the project details of that particular employee, which project he is working on, and the employee details, the employee details of that employee, the name and other type of things. So now there are two type of employees in our company: casual and contractual. But the problem is, contractual employee is contract based. It is not employee of this company. So the function get employee details should not be there for us. It should be there for that third party company, from the from which those contract based employees have their, you can say, like, payroll. So this function should not be there. So if we see in this case, I employee I employee is having these I employee is having these two methods, which is correct. Sorry, casual employee is having these two methods, which is correct. But contractual employee should not have this method. So there can be a case like, you will say that, okay, so we will like we will return some empty thing, or we will return some exception, but it is not needed. It is not needed at any case. So what we can do is, we can do something like this. We can we can have these two classes where we are following the interface segregation. We have segregated the interface according to their requirement. For example, if we make two interface, I employee and I project. So what it will do is, contractual based employee will only implement I project, because I employee does not concerns him. And casual employee will have the both interfaces, I employee as well as I project, because casual employee should have the employee details as well as the project details both. So yeah. So now, from Android perspective also, we can have some examples. So let's suppose there is a login activity. uh, uh, let's suppose first we need to have some gestures. We need to follow some gestures in our application. So there are three gestures: tap gesture, double tap gesture, and long tap gesture, let's suppose. So now there are two activities: login activity and main activity, matlab user main activity, where our view is happening. So now uh, uh, this implementation says that all the gesture functionality will be there in the login view as well as user view. So, but according to some requirement, we didn't need to have the double tap and long tap functionality in our user view. So these two methods will be empty, and it is of no use to user view. So the code will work fine. But if these two functionality is not needed, So can we do something like can we change something here? So yeah, maybe so we can do the same thing that we did earlier. We can have something like this. Yeah. So if we make three interfaces, tap gesture, double tap gesture, and long tap gesture. So now, if in future any other third view comes, any other third activity comes, which needs to implement any two type of gestures, let's suppose tap gesture and long tap gesture, and maybe double tap gesture and long tap. So we need to just implement that particular interface. So we have segregated all the interface according to their functionality, and uh, and we just implemented all the interfaces according to our need. So now if you see this user view needed only tap gesture, and it only has what it wants. So you can say this interface segregation principle is single responsibility principle following with interfaces as well, because every interface is only being implemented by the client which is relevant to them. So like see I have made I am having a one screenshot also. So if you open like view.java, you will see many interfaces, almost maybe 15 to 20 interfaces. All these interfaces are doing the same thing. All these interfaces are having the interface segregation principle being followed. For example, on drag listener, on long click listener, on click listener, on context click listener, etc. etc. So all these listeners are doing the same thing, because let's suppose your view.java is having these listeners. Now your view, let's suppose xyz view.java needs to have long click as well as uh, the drag listener. So what you will do is you will just implement these two particular listeners, and you are good to go. You don't need to have all the listeners. You don't need to have all the listeners to like implement uh, again and again. You can say. So yeah, so that is the case. So here uh, this is working. So now we are coming to an end. So this is D, the last principle of solid, which is dependency inversion principle. It is very important. It is very important to understand, because the modern architectures like clean architecture, I think clean architecture is the latest and most robust architecture that every like startup or every company or every website or everything everyone follows. So the crux of the clean architecture uh, is being derived from this dependency inversion principle. I will let you know afterwards in the coming slide. So first, what is this dependency inversion? It says that high level objects should not depend on the low level implementations. So yeah, let's suppose you have an application. So you will have one activity class, and let's suppose you will have one activity class, and you have a database provider class. It is very simple application. So you have these two classes, activity class and database provider class. So now activity, it says that activity should not depend on the database. uh, Basically now you will say that if it will not depend on the database, then how it will work? So depends means it should be loosely coupled. Now what is loosely coupled? Loosely coupled means every like your activity.java and database provider.java, these are two classes. So these should be working interchangeably interchangeably. It should work like if you are like replacing activity.java to activity2.java, then also it should work. The database functionality should not depend upon the activity UI functionality, and UI functionality should not depend upon the uh, should not depend upon the database. So so this thing, the dependency inversion says abstractions should not depend upon the details. So Yeah, I'll tell you one more example. Yeah, see, so let's suppose you have a car. Now, it does not depends on its engine, right? Because let's suppose it has some type of engine. So same type of engine can be in Maruti Suzuki, same type of engine can be in Honda, same type of engine can be in Tata or Mahindra. So uh, car does not depends on the engine. It depends on the abstraction of an engine. Basically, you can say car should have engine, but how the engine is made, uh, car does not need. So think of it in software terms. How often we build an engine before we drive a car? Whenever we drive a car, do we build the engine again and again? We don't, because engine was made by someone, and it is like, you can say, a single entity, which works uh, independently of the car, independently of the company of the car. You can say there is one more example, which I think which is very like basic example. A real day example is, let's suppose you have a television remote. Now, television remote needs a battery, right? Now, it does not says which brand of battery, because battery and television remote are loosely coupled. You can have any type of any brand battery. You can have Duracell as well, and you can have Eveready and any type of company's battery. You just need to have a AA battery for the remote, and your remote will work. So you can say that it your remote depends on the abstraction of the battery, but it does not depends on the concrete battery. Like the same battery, you need to have this battery only. You can have any type of battery. Just go to any store, and you can have any company's battery. Just it should be, let's suppose, AA battery or something. So yeah. So now, let's take one example also to make it more understandable. So yeah, so let's suppose there is a email class. One function, which email class does is send email. So now I am triggering. Now there is a notification class as well. Now what this notification class does is, notification class is triggering an email whenever some type of notification is received. For example, if you see, whenever promotional notification is received, you will send one email. Let's suppose. Now, what if I need to send a notification by SMS? There comes a new requirement that you need to have the functionality of the sending the notification by SMS also. Now you need to change this object. Now you need to change this notification object, which means it is dependent on email. So notification is depending on email class. But as this principle says that the high level module does should not depend on the low level module. High level module should not depend on the low level module. So uh, notification is depending on email. So notification cannot work if we, like, let's suppose, if we remove email, if we delete email.java, notification will not work. So now what is the solution? Let's suppose we need to have notification by SMS also. Maybe okay, so we don't have time. So yeah, I'll just take the solution. So what we have to do is, what we will do is, we create a interface like iMessenger interface. Let's suppose. Now we created two class, public class email, public class SMS, extends, sorry, implements iMessenger, and we did the code according to the email and according to the SMS. Now you will see that this is also having one problem. What problem will have, in this notification, public notification, we made one object, right? Private email, and email is equals to new email. So now if we do like this, what we will do is, we will use something like this: private, instead of private email, we will do something like private iMessenger. But now we cannot create the cannot create the object of interface, right? Like, for example, email is equals to, sorry, iMessenger is equals to new iMessenger. So it will not work. So now how it will work? So there are many methods of injecting this dependency to our code so that it follows this dependency inversion. So that is called like dependency injection. So this is the problem that I was talking about. That we created private iMessenger, and then in our constructor of notification, we did like this: iMessenger is equals to new email. So it didn't solve our it didn't solve our case, because we need to replace this. Let's suppose I told you that now also notification is dependent on email, which is wrong. So now what is the solution to it? So like there are many many injection techniques. There are very simple techniques. I am sure you must have been using these techniques in your code every day. So this is the first technique, constructor type of injection. So just pass uh, the correct iMessenger object, and now if you do like this, then this notification class is not dependent on your email class or SMS class or any other type of another class. It is like it is only depends on the iMessenger. So if you see the definition again, high level modules should not depend on low level modules. Both should depend on abstractions. So this iMessenger is basically nothing but uh, this iMessenger is nothing but an abstraction which is having the functionality of send message. So iMessenger, so this was the constructor injection. So the second one is property injection. Now, what is property injection? Just to make let's suppose you made one iMessenger object, and made one getter setter method to set the correct iMessenger object according to email or SMS, and just you made the API like something like iMessenger dot send message in the do notify. And this is the third type of injection. All these can be you can use anything. You can use constructor, you can use property, you can use method. So method injection is nothing but like just send the iMessenger object in the do notify method, and it will work. So this is the case. So we can use this class without hampering the existing class. We can use email class without hampering SMS. We can use SMS without hampering email notification. We can use notification without hampering these class. So now what are these levels? How to like say what is the level? I just said that in definition, high level module should not depend on low level module. And I just said that notification is high level, email is low level. So now how to define what is high level and what is low level? That is the main question we come. So see, this is a cone of clean architecture. As I told you that dependency inversion is like used by, you can say, almost every company, every startup is shifting to clean architecture. So I will like tell you what is clean architecture in very short, in very brief way. So it refers to organizing the project. It refers to organizing your whole application in such a way so that it's easy to understand, easy to change as the project goes, and easy to like replace any layer. Like clean architecture is depending on these layers. For example, infrastructure layer, adapter layer, application layer, and domain layer. So you can remove any layer and inject any other layer in it. For example, we are changing the UI, which is infrastructure layer. So infrastructure layer should not depend on sorry, adapter layer should not depend on infrastructure layer. So if that is the case, what will happen? If we if in future we need to change the UI, then obviously we don't need to change our APIs, we don't need to change our use cases, and we don't need to change our entities. We will only work in the infrastructure layer, and we are good to go. Let's suppose in future we need to change the APIs. So we will change this adapter layer, and infrastructure layer and the entities will be will not be hampered. Anything not break. Only we will change the API layer, that is adapter layer, and everything will work. So these are the levels. So this is the lowest level, the UI is lowest level, and entity is the highest level. So what it says is UI depends on the database, and database depends on the entities. Use cases is you can say like use cases is some use cases also. So like UI depends on the controller, that is database. Database depends on some use cases, and use cases depends on the entity. But uh, entity should not depend on the database. Obviously, if we have like made one table, we have done something like uh, entity like uh, some table. So if given it is a MySQL, given it is SQLite, given it is Postgres, any type of database, that entity should not change. We can change the database layer anytime, then entity should not change as well as UI should not change. What if in our application currently we are using SQLite DB, and in future we need to change our SQLite DB to Postgres. Now what will happen, if UI is dependent on the database, then what will happen, if you are changing just the database from one database to another database, UI will break, and that should not be the case. So if you are following this dependency inversion, then every class will be reusable, you can say. So any type of entity, any type of software entity should not depend on each other. So yeah, you can read on clean architecture on internet. So yeah, it is very vast topic. Yeah. So to conclude this, keep these solid principles in mind every time when you code. And there is one more thing. That Robert Martin said in his paper, that don't repeat yourself. Now, what is the meaning of this? Don't repeat yourself. Don't repeat yourself means, let's suppose there are some common 4 lines of code. Now you have to use that code again and again, and you are maintaining these 4 lines of code at 3 places. So now you have common 4 lines of code, and that common 4 lines of code you are maintaining at 3 different classes or 3 different places. Now let's suppose you had one Jira issue, you had one ALM issue, and there you found a bug in that particular 4 line of code at one place, at one class dot at let's suppose class A dot Java. Now you will fix that bug and push that code, so you will see that, okay, yeah, my issue is solved and everything is working fine. But now too, as I told that those 4 same lines of code were having in the 3 different places. So 2 places is having that bug that is not fixed yet. You have fixed only at that one place. So what if you had made a function of it and use the same function again and again? It will be fixed in all the 3 places. So, apart from these solid principles, Robert Martin said this thing also, that don't repeat yourself. Every time you need to have a functionality. So just make a function, make a maybe abstract class out of it, or maybe extend that class so that you can like follow the open and close principle, and do your changes there. Only this Liskov substitution principle needs to be followed. It is not it is not mandatory. You can follow as per your needs, and even if you're not following this Liskov substitution, 50% of the times, I'll not say 100%, but maybe 60 or 70% of the times, you will be good to go. So yeah, these were the principles. Uh, so yeah, if you follow this, bugs will reduce, and code will improve automatically. Just whenever you are like doing anything, you need to follow these principles. And even if you like now read about MVC, MVM, or any type of Android architecture, clean architecture, anything, you will see that uh, the basic building blocks were these only, these 5 solid principles that we discussed today. So yeah, that's all. I'll share this PPT as well. Hello, Mayor. Hello, Avinash. Yeah, what's your doubt? Can you tell me?
No, I just sort of clarifying whether the clean architecture can also fall in, like we are using the view models repositories, right? For
Yeah.
various business logics and all we will
Hmm.
set it, right?
Hmm.
So I think that will that also fall under clean architecture, right?
No. Actually, clean architecture is generally used for, you can say, business entities. For example, let's suppose there is a company, everyone knows Amazon. So now, what Amazon is doing, Amazon is following this clean architecture. Now, how they are following, I'll go to this again. So see, there are many layers. Now, Amazon is very big company. They are having the APIs. They are having some maybe APIs. They are having some UI, which is web based UI as well as device based UI, or the third party UIs as well. For example, they are having admin panels of the vendors as well, and everything. So in any case, if let's suppose APIs are being changed, so the UI should not affect. So that is the case. And if you ask me about this view model MVVM, then MVVM is, you can say, it is obviously it is following dependency inversion, but it is different from clean architecture because clean architecture only says that UI should not depend on UI should depend on database should depend on entity. It is only one way flow. Like if you see in this diagram, infrastructure will depend on adapter will depend on application can depend on domain, but not other ways. But in view model, it can be the other way around also. Like for example, in Android also, if you want to have some if you are like populating some database according to the users according to users input, so obviously which means that your UI is your database is depending on your UI, because on the user input you are like updating your view model, and accordingly you are updating your view as well as your repository. So view is basically, you can say, view model is, you can say, it is the middle layer between the view and repository, and it is a two-way communication. But in this case, because repository will tell view model to update view, and view will tell view model to update repository, let's suppose, just to understand. But in this case, it will flow only in one way, matlab, you can say. So that is the difference between this view model and clean architecture.
Yeah, okay, Jay. Thank you.
I think Meher is not there. So shall we wrap up? Puneet, can we like, is there anything? Uh,
No, Jay, thanks.
yeah, okay. So I'll share this PPT into the same link. So yeah, you can go into that. And like, if you want the one more PPT on design patterns as well, like the difference, what is factory pattern, what is builder pattern, and all, then yeah, we can have this PPT as well in future. So yeah, just let me know. Yeah,
Yeah, thanks, Jay, for a good
yeah.
session.
Thank you.